Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSC Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science
So the
courses.
question says, I define a function f of n. It is 1 by 3 to the power n plus square root of 3. And I want to find the value of s, which is given by root of 3 times f of minus 5, f of minus 4. And it goes all the way to f of 6. So there is a way you can think about this problem. So this function takes values from minus 5 to 6. So think about a function that will give you these integers minus 5, minus 4, minus 3, and up to 6. If I pair it, why? So it's not difficult to think. If I take a function, say so on one end it's minus 5 and on the other end there is 6, and there is some kind of a shifting by a 1 to the left. What I mean to say is, so if I just say take a function g of n, which is like 1 minus n, and if you put n equals to 5, you will get a value of 4, minus 4. If you put the value of n equals to 6, you will get the value of minus 4. Or maybe just write it the other way. So if I take n equals to 6, I'll get the value of minus 5. If I take n equals to 5, I'll get the value of minus 4. And it goes on till n equals to 0. For that, I will get the value of 1. Right? Yeah. So there is a way we can pair it. I can pair this minus 5 with 6 and pair this 5 with 4. You will soon see what is this pairing I'm talking about. But this is a way you can think about it. Because the problem is not that straightforward. You will have to do some construction or some sort of manipulation. So for 0, we can pair up with 1. So what I mean to say is, I want to see how this function behaves if I take this pair at first. And then I'll take this pair. And then take the rest of the pairs. And there will be n equals to 0 that will be left for me. So what I mean to say is, just forget about this. Because there is this resemblance of minus 5 with 6, this connection of minus 5 with 6, minus 4 with 5, and so on. What we can do is just see how the function behaves for f of n with f of 1 minus n. Why am I taking this? I'm taking this because this is a way of pairing, an exhaustive way of pairing. I can consider minus 5 and 6 from here. If I take n equals to 6, if I take n equals to 6, I'll get f of minus 5 plus f of 6. If I take n equals to 4, I'll get f of 4 plus f of minus 3, so on. So let's see how does this function behave. So there can be a million ways to tackle this problem, but out of the ways you need to think for that particular way, which is kind of makes sense. So this does make sense. There are different ways it can make sense, but this is one way you can think about it in these kind of problems. So if I do this, you will see that this is 1 by 3 to the power n plus root 3, and this will be 1 by 3 to the power 1 minus n plus root 2. So, so what I can write is I can multiply 3 to the power n both sides, the numerator and the denominator. I will get 1 by 3 to the power n plus root 3 plus 3 to the power n by 3 plus. So this is easy. It's just you can take this term as the LCM, and you will get a root 3 here and end up with 3. So I'll just what I can do is I can take uh, root 3 common with the numerator. Sorry, at the denominator, and we will get root 3 plus 3 to the power. So what I did is um, so just take a root 3 common from here, you will end up with 3 to the power n plus root 3, and you can cancel that out, and you end up with this beautiful result which says that this value is always 1 by root 3. Oh, you can cancel it because obviously it's positive and cancel. So what you get is for any value of n, f of n plus f of 1 minus n is always 1 by root 3. Now the problem is pretty simple. Just sum these values for, I mean, so for n equals to 0 to 5. Yep, that's how you'll get it, or maybe 1 to 6. Now what I can do is I'll take a summation. I'll range it from 1 to 6. I also have this summation from n equals to 1 to 6. So this is pretty straightforward. You will get 6 times 1 by root 3. And what is this? This is if you put n equals to 1. It's all an intrinsic property of the way I have chosen this whole function f of n plus f of 1 minus n. Because of the way I've chosen this, you will get the first expression. You will get all the terms. F of 1 plus f of 0, then f of 2 plus f of minus 1, f of 3 plus f of minus 2, plus f of 4 plus f of minus 3, f of 5 plus f of minus 4. And finally, you get f of 6 plus f of minus 5. If you see, it's stop. It's like the sum you are asked to find. Instead, what you are asked to find is this sum product with root 3. There is a root 3 multiplied with it. It is nothing but 6 by root 3 from here, and you multiply with it with root 3, you get this value as 6. Okay. So, do you have any questions? So, the answer is 6.
To book a trial class for your preparation courses of IITGM MS, ISIM STAT, and CMI MSC Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.